So now I'm going to talk about the range in projectile. What is range? It's the last ground to ground projection case one parts. So range. Now what is range? By the maximum distance covered by a projectile body from the point of impact. Maximum distance covered by projectile body from the point of projection to the point of impact. Projectile from point of projection to the point of impact in x direction. When we talk about x direction, we are only concerned with the x-axis, not concerned with the y-axis. So the maximum distance is something like this. The maximum distance covered by a body from the point of projection to the point of impact is known as is basically known as range. Now what is range and how to deal with it? Let's make it here. So we know that the Sx is equals to, let's find out the distance from point of projection to the point of impact in that direction, right? So we know that the Sx is equals to VIT plus 1 divided by 2 AT square. Let's deal with it. So we know that this Sx remains same. Sx remains same is equals to, which velocity are we concerned with here? Vi. For the u direction velocity, x direction velocity, this is u cos theta. For I'm using O because I don't know where to insert theta here. So plus, and we know that acceleration in the x direction is always 0 because it moves with constant velocity. So 0, and then closing this bracket again. So we know that this complete factor will be, I'm sorry. Oof. So we know that the, let me use this mark here, no problem. This complete factor will be 0. This VIT wala complete factor will be 0. So this equation will be something like this, right? So Sx is equals to, Sx ki jagah we can write range. Range is equals to, then we can write, what we can write here? Sx is range is equals to u cos theta t. Now what is t here? T here is basically time of flight. We can say that the t here means time of flight. This is time of flight. Time of flight. This is tx here is the time of flight. So now we can insert that formula here as well. So let's write it here. Range is equals to, I'm writing the complete formula. You can insert that by yourself. It will be something like this: u cos theta multiply. For multiply, I can use the dot. C as u sin theta divided by 2. So after complete calculation is something like this. There will be the double angle identity, which is u cos theta is equals to 2 u square. After completing and solving all that, I won't be solving. So this will be okay. I'll be solving again here, so that you can understand what does it mean. Now we know that when u multiply by with this u, it will be something like this: u square, then cos theta, sin theta, cos theta, sin theta, and then again I'm going to write here, not 2, it's g. Erase this factor here, it's g. 2u cos theta sin theta divided by again g. And we know that the 2 cos theta sin theta is a double angle identity. Okay, let me write it. Wait. That 2 cos theta sin theta is equals to 2 sin theta. So there we can write here that range is equals to u square sin 2 theta divided by g. Okay? So this is basically a formula of range. So now what is the angle of range? At which angle the range of the the range of the projected body is maximum? Let's deal with that as well. So let's see. Okay, so range. Now let me make a diagram again. For example, this is a body, this is a ball, again a ball. This ball is projected from here to here. This is a point of projection, a point of impact. This is u cos theta, this is u sin theta, this is the initial velocity. Then I'm not writing here, but again and again it's too good to write. So now I would like to include one point here, that range is same for complementary angles. What does it mean, and what the maximum angle we obtain? At which angle the range will be maximum? Range is same for complementary. Same for the complementary. You know that the formula for the range maximum is, now I'm writing here. The formula for the range maximum is, let's write it here. Let's raise it first of all. Okay. Formula for range maximum is R is equals to Q square divided by G. This is basically a formula, and we know that the range is equals to U square sine 2 theta divided by G. And since we know that the sine 2 theta is equals to 1, and whenever will be the value of the sine theta is 1, which means it's maximum, right? We know the sine 2 theta is equals to 1, 2 theta is equals to 90 degree. So the ultimately theta is equals to 45 degree. So the angle 45 degree is the maximum angle at which we will obtain the maximum range. This 45 degree is the maximum angle at which we will obtain the maximum range. Let's make an angle here. This is something like this. This is projectile. Okay, let me make it again. This is a straight line. Okay, this is a projectile path. Okay, right? So this is u cos theta, x direction. This is y. This is initial. So this is u. So this 45 degree will be the maximum angle at which the range of the body range will be maximum. And ahead of this, instead of this, we read one point that the angle is same for the complementary angle as well. It means that for the angle theta and 90 minus theta, the angle of projection or the maximum range is same, 90 minus theta. For example, if we project a body, for example, I'm not making a complete path. Now I have projected a body at 30 degree. Then I have projected a body at 60 degree. However, their velocities are same. I have projected body with different angles, but their initial velocity is same. So their maximum range or the angle or maximum range is same, which is 45 degree. Right? So this is obvious thing that the angle at 90 minus theta or theta, the angle of projection is same, which is 45 degree, and it's maximum. So yeah.